All right, now this is the important part. Factoring quadratic expressions. So a quadratic expression is an expression where the highest exponent is a 2. All right, so let's refresh. Let's distribute. X times x, x times 5, 1 times x, 1 times 5. And then we combine our like terms. What we are doing, instead of distributing, combining like terms and getting this quadratic, is we're starting with the quadratic and then going back to the factors. We are undistributing. So to factor quadratic trinomial, so 3 terms, x squared plus bx plus c. The key on this, I want you to underline it or highlight it. This x squared has a coefficient of a positive 1. Positive 1 here. You must find 2 integers that multiply to c, so that's this term, and adds to b, so that's this term. So if I'm factoring this quadratic expression, the first thing I'm going to double check is that the leading coefficient is a positive 1. It is here. So what 2 integers have a product of 12? That's the c. So I'm going to look at my factor pairs of 12. So 2 numbers that multiply together to be 12. So that's 1 and 12, 2 and 6, 3 and 4. These are my factor pairs. Because when I multiply 1 times 12, I get 12. 2 times 6, I get 12. 3 times 4, I get 12. So 2 integers that have a product of 12 and a sum of 7. Well, that is 3 and 4. Okay, now write the 2 binomials using these integers. Okay, so I got to think what 2 numbers multiply to be x squared, excuse me. Well, that's x times x. Because remember from up here, x times x was x squared. The second value, the one that goes here and the one that goes here, is your 3 and your 4. It's a positive 3 and a positive 4. Now, the question that gets asked a lot is what happened to the 7? Okay, well, let's redistribute. X times x, x times 4, 3 times x, 3 times 4. Combine your like terms. That's where your 7 is. It's built in. It's part of your factor pairs. So you want to verify that the leading coefficient is a positive 1. That's a positive 1. Awesome. So I want factor pairs that multiply to c. Okay, so that's 20. That's 1 and 20. 2 and 10. 4 and 5. They need to add to b. So that is the 9. In this case, let's do this. Multiply to 20. Add to 9. So that's going to be your 4 and your 5. Okay, so start with your n squared. What 2 terms, when you multiply them together, get you an n squared? N times n. What goes next? Positive 4, positive 5. Now, where did the 9 go? If we redistribute, combine your terms, that's where your 9 went. It's built into your factors. Okay, example 2. Verify that the leading coefficient is a 1. That is the coefficient of your square. There is my square, and its coefficient is in fact a positive 1. So I want factors that multiply to 18. It's your constant. 1 and 18, 2 and 9, 3 and 6. They also have to add to 9. So multiply to C, add to B. And that's going to be our 3 and our 6. And what goes second? Positive 3, positive 6. Okay. Double check and make sure your leading coefficient is a positive 1. It is. Awesome. So multiplies to the C, and that's 1. So that's one factor pair. It's 1 and 1. Has to add to be the B. That's 2. Well, does 1 plus 1 add to be 2? Yes. So what gets me y squared? Y times y. What goes next? Positive 1, positive 1. Okay, next one. Again, we want to verify that the leading coefficient is a positive 1. Our leading coefficient here is a negative 4. So that means we want to look for GCFs. So in this case, can you let me erase that? Thank you. In this case, we want to divide everything through by a negative 4. Okay, so it's going to give me k squared plus 3k plus 2. Okay, so we divide by negative 4. Negative 4 cancels. That's 3. That's 2. All right, now I'm only going to look at the inside. I'm going to kind of cover up that negative 4 for now. Now, as I look on the inside, its leading coefficient is in fact a 1. So I want factor pairs that multiply to C. There's only one factor pair. Has to add to 3. Does 1 plus 2 add to 3? Yes. Okay, so factor pairs. So k times k. And then our factor pairs were positive 1, positive 2. But guys, if I were to redistribute this, just this, I don't end up with the original. What was missing? GCF. You want all the factor pairs. All right, this time I'm changing the signs. These are all positive. Now I'm saying the C is negative. Your constant is negative. The rules are still the same. They multiply to C, add to B. Check that your leading coefficient is a positive 1. Awesome. So multiply to negative 18. Okay, so the problem is it's multiplying to be a negative 18, which means something has to be negative. One of your factors has to be negative. Okay, but it also has to add to 3. Okay, so that is a positive B. For that to work, the positive has to outweigh the negative, which means your big factor is the one that stays positive. Your little factor is the one that's negative. Okay, so we say little factor negative. Okay, so now a parenthesis n squared, so that's n. I have a negative 3, so minus 3, positive 6. All right, check that your leading coefficient is a positive 1. Awesome, it is. So I want factor pairs that multiply to negative 8. So that's 1 and 8, 2 and 4. But again, issues that it's negative. But it also has to add to positive 2. Okay, we've already established the little factor is the one that's negative. So the one that adds to be positive 2 is negative 2 and 4. So x squared, so that's x times x, negative 2, positive 4. Verify that your leading coefficient is a positive 1. It is. Awesome. So we want factor pairs that multiply to negative 6. So it's 1 and 6, 2 and 3. The issue is that it's a negative 6, so something has to be negative. So it has to add to that. Well, that's a positive 1. Okay, we've already established your little factor is the one that's negative. Okay. So y squared, that's y times y. And the factor pair that adds to be positive 1 is negative 2 and positive 3. So it's a negative 2 minus 2, positive 3. All right. Leading coefficient must be positive 1. It is not. So it has a GCF. May have a GCF. In this case, it's 2. All right, so if I ignore that 2, now my leading coefficient's a positive 1. So I want factor pairs of negative 16. So 1, 16, 2 and 8, 4 and 4. But again, issues that it's negative 16. So something has to be negative. So our B, add to 6. Little factor negative. So it's going to be negative 2 and 8. So k squared is k times k. And the first factor, minus 2. Second factor, plus 8. Do not forget your GCF. It is a factor. All right, in this section, we are changing the signs yet again. This time we have a negative b and a negative c. All right, the process is still the same. You want to find two integers that multiply. And add to b. Okay, and that leading coefficient must be positive 1. It is, so we're good. So we want factor pairs that multiply to negative 3. So that's just one pair, 1 and 3. But they have to add negative 2. Okay, so if I'm adding and I want to keep the outcome negative, then the negative has to outweigh the positive. Okay, so just like on this one, where the positive outweighs the negative, and the little factor was negative, if the negative outweighs the positive, then it's the big factor that's negative. Now, go over here to our parentheses. I want to think, okay, n squared, that's n times n. And then I have a positive 1 and a minus 3. Now, as far as where that negative 2 goes, well, if we redistribute, that's n squared minus 3n plus 1n minus 3, and we combine our terms. There's your negative 2. So it's built in. All right, we have x squared minus 7x minus 30. Make sure your leading coefficient is positive 1, and it is. If it happens to be a negative, factor out the negative sign. It's not, so we don't have to worry about it. So there's my c. So factor pairs that multiply to negative 30. That's 1 and 30, 2 and 15, 3 and 10, 5 and 6. All right, so the big factor is negative. So we want factor pairs that multiply to negative 30 and add to negative 7. And I can see that happening right there with 3 and the negative 10. So we've got our parentheses. Think about your x squared. That's x times x. And I've got a positive 3, so plus 3, and a negative 10, so minus 10. Okay, now I might have to change this one because I realized that I have that exact same problem over here on number 4. So I changed it. This is negative x squared plus 3x plus 40. So that leading coefficient must be positive 1. Right now it's negative 1. So we're going to factor out a negative 1. Okay, so that makes your x squared positive, makes your 3x negative, and makes your 40 negative. Okay, now there's my c. So multiply to negative 40. 2 and 20, I don't know why I wrote 42. 2 and 20, 3 and, nope, not 3, so 4 and 10, 5 and 8. Okay. They also have to add to negative 3. Okay, remember the big factor is the one that's negative here. And there's the one that adds to negative 3. So x times x right here, that's x squared. And I've got a positive 5 and a negative 8. And don't forget your original GCF of negative 1. All right, leading coefficient here is a negative 2. So I'm going to go ahead and factor that out. So it's a positive k squared, negative 4k, negative 12. Okay, so we want factor pairs that multiply to negative 12. Okay, that's my c right here. So that's 1 and 12, 2 and 6, 3 and 4. And they also have to add to negative 4. And since they add to negative 4, a big factor is the one that's negative. And I can see that factor there. 2 plus negative 6 is negative 4. So we've got this k squared, so that's k times k. Positive 2, so plus 2. Negative 6. And don't forget your GCF. Okay, last step. This time we're changing the signs one more time. We have negative b and positive c. So b is the one that's negative, c is positive. And it's still the same process. Multiply to c. Add to b. Okay, leading coefficient must be positive 1. Positive 1, awesome. So there's the c. Multiply to 49. Okay, now it's got to add to negative 14. Okay, so the problem is it has to multiply to be positive though. In order for that to happen, either both factors have to be positive or both factors have to be negative. All right, well, if I'm adding to be negative, then to keep the negative sign, my factors must stay negative. So with a negative b and a positive c, both factors are negative. Because a negative number times a negative number is positive, and a negative number plus a negative number is still negative. So it has to add to be negative 14. So that's going to be your negative 7 and your negative 7. Got x squared, so that's x times x, negative 7, and negative 7. All right, I definitely repeated this one on example 1, so we're doing great. So I've changed it. Negative x squared minus 15x plus 50. Okay, so so first thing is that your leading coefficient must be positive 1. It's not right now, so you need to go ahead and factor out the negative 1 to make that a positive x squared, negative 15x, and positive 50. All right, well, there's our c. So it's going to multiply to be 50. So it's 1 and 50, 2 and 25, 3, no, 4, 5, and 10. I think that's probably it. But then it also has to add to negative 15. Okay, we've already established that both factors have to be negative. Well, the pair that adds to be negative 15 is negative 5 and negative 10. Okay, so I've got my x squared there, so that's x and x. Got negative 5, negative 10. And don't forget your original GCF of negative 1. Make sure your leading coefficient is a positive 1. It is. So I want factor pairs that multiply to 72. Okay, there's a bunch here. So 1 and 72, 2 and 36, 3 and 24, 4, and 18, 6, and 12, 8, and 9. Okay, guys, I'm doing this in a calculator, Jacob, because I didn't know what 72 divided by 3 is, so I'm doing it in a calculator. 72 times 4. I did not do 72 divided by 5 because for something to be divisible by 5, it has to end in a 0 or a 5, and this one doesn't. Okay, we also know because it's a positive 72, but adds to negative 17, that both factors have to be negative. And I can see the factor pair right there that adds to be negative 17. So I got y squared, so y times y, minus 8, minus 9. Leading coefficient must be positive 1. Right now it's negative 3. So I'm going to divide everything through by negative 3. All right, now the leading coefficient is a 1. So the c value, 4. So multiply to 4. And then has to add to be negative 5. Okay, so the only way for that to happen, multiply to be positive and add to be negative, is both negative. And I can see the factor pair that adds to negative 5 is negative 1 and negative 4. So you got your y squared, so it's y plus y, minus 1, minus 4. And don't forget your original GCF. You enter it in without the GCF on delta, it's going to count it wrong.